We are in Precalculus lesson 2-4, dividing polynomials. Today's date is November 10th, 2020. Our objective for the day is to do what? Who wants to read? Go for it, Chewy.
Divide by monomials and polynomials.
Yeah, monomials and polynomials, yeah.
I don't know why I said it all weird.
So, just a show of hands, how many people remember doing this in Algebra 2? Okay, that's I try to scaffold as much as I can, but it gets really hard really quick. So this might take 2 days then. I can scaffold it over 2 days. So let's start with dividing by monomials because that's nice and easy. The way that this works is I'm going to separate this into separate fractions. So I'll have one fraction that's 3x to the power of 7 divided by x squared. My next fraction is going to be a positive 5x to the power of 4 divided by x squared. My next fraction is going to be negative 3x squared divided by x squared. Let's separate those all out, and then you kind of simplify from there. By the way, once you hit a certain number, once you get to the same degree, then you can just kind of stop. So this is going to be equal to, and you guys can all follow with me, 3x to the power of 7 over x squared plus 5x to the power of 4 over x squared minus 3x squared over x squared. And notice that I've now hit the same degree. I have an x squared over an x squared. Once that happens, or once you can't divide evenly anymore, then I'm just going to write the rest as a remainder. Well, yes, I agree that I can reduce 7x over x squared. I'm just going to write the remainder. This will help you. I'm doing this to set you up for success in the future examples. There is a reason to my madness. So I'm going to just say plus 7x minus 1. That's all of the rest over x squared. So I'm calling this like the rest. And then I simplify. But before I simplify, I want to make sure that everyone can follow along. Do we have questions? Why did I do this? And once you're good enough, you don't really need to do all this work. You can do this in your heads. Because what we're doing now is we're just using properties of exponents. I'm doing, this is x to the power of 7, x to the power of 2. This is really 3x to the power of what? Requires him. 3x to the power of what when I reduce? Chewy?
What's on monomials?
I don't know.
Monomials.
I don't know.
That was weird.
3x to the power of 7 divided by 3x squared is 3x to the power of what? You subtract 7 minus 2, you get 5. So this is 3x to the power of 5. So when I reduce this, I kind of ran out of room here. Maybe I can move this. What's going on here? I can move this over a little bit. I can say when this is reduced, it reduces to just 3x to the power of 5. That was the first fraction. 3x to the power of 5. What is this next one then? Jane, can you close your laptop, please? This next one should be, Leo? 5x squared. Leo has it. Write it down. It's a positive 5x squared, so plus 5x squared. Then minus what? Carolyn? Minus 3. Yeah, those x squareds are totally eliminated. And then I add on that remainder plus that 7x minus 1 in the numerator and x squared in the denominator. Done. And you're doing this over and over again. So this is the way that we used to see it in Algebra 2, but now that we're in Precalculus, we're going to write it slightly differently. We're going to say, hey, my numerator, a of x, is this polynomial. The thing that I'm dividing it by is b of x. What is b of x? I'm dividing it by x. So I can translate this back into the way that we used to know this. Essentially, it's asking us, what is that numerator? What is, and leave some space right here to write our answers. What is 4x cubed minus 8x squared plus 5x plus 2, all of that divided by x? That's our question. They just wrote it kind of weirdly. Notice that the form that they want us to write this in is write out your quotient. Q stands for quotient. Write out your quotient, which for our last problem in red would have been 3x to the power of 5 plus 5x squared minus 3. That's the quotient. Maybe I'll write that down for the notes over here as well. This thing that I've written down right here, this part, not including the fraction. Wow, that's a bad curly brace. This piece right here, that's the quotient. This piece right here, just the 7x minus 1, that's the remainder. So they say, what is the quotient and what is the remainder? They don't care about that b of x on the bottom. Notice it's not asking what is r of x over b of x. They're just asking what is the quotient, what is the remainder? And you guys can probably do this in your heads now because this is x to the power of 1 in the denominator. What should be the first term of our quotient? 4x to the power of 3 divided by x. We can do that. 4x to the power of 3 divided by x. Ellery?
You have 4x to the power of 2.
There it is. Write it down. 4x to the power of 2. What's the next term in our quotient? We have this 4x cubed divided by x. That was our first one. Now I'm going to do negative 8x squared divided by x. Sam? Or was it not him? Beverly? Negative 8x. Is there anything else that we can do? Oscar? Yeah, just a 5. So it's 5x divided by x is just 5. So plus 5. Is there anything else we can do? Beverly again?
I have a question.
Yeah. So one of these.
So for the top one, why didn't we do the 7x? And that was left the remaining.
So yeah, that one could be reduced, but that would make it so that I have a bunch of different fractions. So that is totally valid. You could have said over here, you could have said 7x over x squared, and you could have reduced this to 7 over x, which is fine. But I'm trying to set you guys up for these types of problems where there's only one type of denominator, and that denominator is b of x. This denominator is some other, not x squared. So you could have, but I'm trying to set you up to do problems like example 1, 2, and 3. And also in Khan Academy, they want you to do the same thing that I'm doing here too. So it works out. Yeah, good question. Are we done with our quotient? Is there anything else that I can write in our quotient? Can I write something right here? We've used up the 4x cubed minus 8x squared plus 5x. Can I write 2 maybe or something? The answer is no, we can't. Because the degree of our 2 is 0, the degree of our denominator is 1. We've gone lower than the degree of the denominator. So I just have to write the remainder. The remainder is 2 over x, but again, I don't want the over x, I don't want the b of x, I just want the numerator. I just want this top piece. That's called the remainder. So I'm just going to write 2 here, and then we're done.
Wait, why don't you write the b of x part?
Because it's not asking for the b of x. So notice that the form that it wants over here is q of x plus r over b. It doesn't want the r over b, it just wants the r.
Okay.
All right, let's try something a little bit harder. Can I get a fist 5? How many people have I lost? How well do you understand example 1? We get 3, 5. What is that? A 3, 3. A lot of 5s in the back. 3, and 2. Ask a question, Neil. Should I get that 2 to a 3? We're doing for r. R is whatever's left over. Whenever I can't divide 2 by x because there's no way to reduce that, I just relist the 2. For example, up here, I had 7x minus 1. I couldn't divide those. I mean, I kind of could, but I just relist the 7x minus 1. That would have been the remainder. All right, it's time to get a little bit harder. So let's do long division. Let's say, how do I do 136 divided by 11? And again, this is asking the question, what is 136 divided by 11? It turns into this problem. 11 goes into 136 how many times? And we have to be very, very strict about what we're doing because we're about to do the same problem, but with a polynomial. Look at the similarity between these two problems. I have the coefficients 1, 1. The coefficients are 1x and 1. What about the coefficients for this? 1, 3, 6, 1, 3, 6. These problems are synonymous. This is a polynomial on the right. This is just normal integers on the left. They're going to be the same exact steps, though. We have to be careful about why we're doing what we're doing. Here we go. 11 goes in 136. What do I do? Long division. Valerie?
Well, 11, that was always 1 to the right. 11 goes to the 13 one time. You put a 1 over the 3 and you write 11 under the 13.
Okay, you've done like 5 steps. So let me make sure that we have all of them done because every single step is going to be a lot harder when we transfer it to a polynomial. 11 does not go into 1. X plus 1 does not go into x, right? 11 doesn't go into 1, so you have to expand your search. 11 goes into 13, though. How many times? It goes up to 1 time. Because 1 times 11 gets really, really close to 13. And then you actually do that. 1 times 11 is what number? 11. And we write the 11 underneath the 13, as Hillary said. So 13 and then 11 underneath there. What do I do next? Beverly. I subtract the 11 from the 13. And you get what, Beverly? 2. Next, what do I do? Leo? Bring the 6 on down. Let's use green. So you get 26. Perfect. Now what? Another step. Oscar? You repeat the process again, yeah. 11 goes into 26 how many times, Oscar? Twice. So we write a 2 up here. We say that's 2. And then we actually do the multiplication. How close did we get? We got 2 times 11. That's how close. 2 times 11 is 22. We can write that under here. Do 22. Next step, what do we do? Ellery again? 4. What do I do next? Oster? That is your remainder. You say 12, remainder 4. Done. That's our normal long division just with integers. I guess I should say with natural numbers. 11 and 136 are natural numbers. Now we're going to convert that to polynomial. It's going to be very, very similar. I want you guys to try to remember what you did on the left and apply it to what you did on the right, or what we're doing on the right. All right. X plus 1 doesn't just go into x squared because I need 2 terms for polynomials. So I have to expand my search radius. So x plus 1 does go into x squared plus 3x. 2 terms does go into 2 terms. What do I need to multiply x plus 1 to get really, really close to x squared plus 3x? Oscar? By 2. If I do by 2, then I'll get 2x, which doesn't really get rid of this first term. Again, if we look at what we did over here, we got rid of this first term. This 1, I subtracted 1, and we got that eliminated. We matched up by, I know that my hand over here doesn't hide that minus sign, but I need to match up this first term. 1 and 1, those are the same terms. How do I get x squared and x squared? I want an x squared right here so I can eliminate that. What do I need to multiply this x plus 1 by to get an x squared right here? Beverly? X. So I'm going to write an x up here. And then I actually do the multiplication. How close did I get? I'm going to do x times x plus 1 and write that under here. Who can do that for me? Beverly? Plus x. There it is. Okay. What did we do next? We're moving on to the orange. Sam?
Subtract 3x and x. And you get 2x.
You do indeed, yeah. So we're subtracting everything. So we're subtracting this entire polynomial, and you get 2x. If you haven't canceled out your first term, you've done something wrong. This first term should always be eliminated because it should always match. A very common mistake is forgetting that this second term is supposed to be subtracted. So if it helps you, you can distribute this negative into each of these terms to switch the signs of each of them. So it's a negative x squared and a negative x, and then just add down. But really what we're supposed to be doing is we're subtracting this polynomial from this polynomial. All right, what do we do next? We're on to the green. Emily? Bring down the +6. And then we restart the process again. I want to match up a 2x under here. I want 2x and 2x. How do I get a 2x here? What do I need to multiply this x plus 1 by to get a 2x? Close. 2x times x is 2x squared. X times x is x squared. What times this x will give me 2x? Well, 3 times x would be 3x. So 2. And we'll write that above the 6. I'll write the 2. 2 times x plus 1, Sam, is what? 2x plus what? Because you have to distribute the 2 into both of these two terms. There it is, yeah, plus 2. Yeah, Jaden. The office does.
Is it fuzzy?
Yeah. Just like irritating. Plus.
Okay, I would go talk. Oh, Miss Heather's going to be out at lunch. I would go ask Miss Heather right now.
I don't know. I mean, it'd be nice to like not have to like.
You can ask after we're done with the lesson, which might take the whole class, but I want you to be here for this. All right, what do we do next? We just did green. I'm on to the black. Oscar? Say that one more time. X2 remainder 4, or X, so this is going to be plus 2, I guess, remainder 4. Yeah, you're correct. How'd you get that?
So you just subtract that, and the 2 gets canceled out.
Remainder 4. Perfect. Yeah, and since it's X2, this is a positive 2, so we could have written a plus 2 here. Yeah, and the remainder is 4. And remember what we do with remainders. So back here with 12 remainder 4, this can be rewritten another way. This is the same thing as 12 and 4/11ths. Why? Because the original thing I was dividing by was 11. So my remainder, I just put that in the numerator, and I write my original divisor, 11, in the bottom. So instead of saying remainder 4, I'm going to say something else. Instead of remainder 4, it's going to be what? Ellery?
You have x plus 2 plus 4 over.
There it is. Plus 4 over the original thing I was dividing by, x plus 1. That's long division with polynomials. And there were cute little shortcuts that we learned in Algebra 2, but those only worked in like 1% of the cases. In this lesson, I'm going over the other 99% of the cases. All right. So here we go. My mega polynomial looks like this. x2 plus 2x squared minus 3x plus 1. What am I dividing that by? I'm dividing by x squared plus 5. Set up your long division. Here we go. And again, leave some room to write your answers for q of x and r of x over here. And our long division looks like this. We have x I might need more room. X squared plus, or x cubed, what am I saying? No, x squared plus 5, because that's the thing that I'm dividing by, goes into x cubed plus 2x squared minus 3x plus 1. I want to say this now, even though it doesn't affect us. If I were to skip over a value, for example, what if I didn't have this 2x squared here? What if this was x cubed minus 3x, and there was no 2x squared here? You need to leave a placeholder value. If there was no 2x squared here, right here, I wouldn't just leave it blank. I would write 0x squared. Whenever you skip over a term, like an x squared, an x, or anything, if you ever skip a term, you need to leave a 0 in its place. Otherwise, you will get the wrong answer. Okay, it's the same process again, now with this new problem. We're working on this together. If you know how to do this on your own, please go ahead of us. You can do all of these now. As a heads up, for example, number 2, you'll need 2 placeholder values. You've skipped your x cubed, you've skipped your x squared. Those are 0x cubed, 0x squared. And example number 3 is, that's the final level of difficulty that they get on Khan Academy. I'm dividing by something with 4 terms. That's the hardest type of problem I can put on the quiz and the test. I don't think we're gonna get to all of them today. After example 1, Jaden, if you can talk to Heather, then that's a good time. But let's finish example 1 first. And yeah, okay, so first step, what do I do? Again, our whole goal is we're trying to get x cubed and write that under here. Beverly? Times by x, yeah. So I'm going to go ahead and do this step in blue. We're going to multiply by x. I always write x above the other x. I don't put x here or here. I put it over the other x because it lets me know when I'm about to finish the problem. Once I get to here, then I have the remainder and then I'm done. So if I multiply x squared plus 5 times x, hopefully that matches up and I get an x cubed under here. Beverly, can you multiply that for us? What's x times 5? 5x, yep. You're good. Notice where I've written these. I did not write plus 5x underneath the 2x squared because 5x is not like terms with 2x squared. The like terms are negative 3x and a 5x. Be careful about where you write your numbers. The integer equivalent of x squared plus 5 wouldn't be 15, it would be 105 because you skipped a place. So be careful. All right, so we've now distributed our x into our x squared plus 5. We've written it underneath. What do we do with these 2 polynomials now? Oscar? Yeah, question.
What is that x? How does that finish x?
Great question. Does anyone else want to answer that? How did we get x cubed here? You can call something.
Oh, question.
Let's do the answer then the question. If that's okay.
When you multiply by x, like it adds another power to it because it's x to the like 1 power, and when you multiply, you add the power.
So if it was just x, it'd be x squared. If it was x squared, it'd be x cubed.
Yep.
Okay.
Yep.
What do you do with the negative?
Can you answer your question one more time, please?
Do you just put a 0 for the plus 2x?
Oh, like under here?
Yeah.
You can put a 0 if you want. I'm just going to leave it blank because it'll keep us honest about if I distribute x into these 2 terms, I still get 2 terms out. And it's just personal preference. All right, what do we do next? Who have I not heard from today? I haven't heard from Aurelio or Jaden. help us out. It's the same steps over and over again. What do we do next?
Sorry.
Okay, I'll open it up to anyone. Anyone, help me out, Beverly. I'm going to subtract that polynomial. So I'm going to write over here, I'm going to do that polynomial. I'm going to subtract it. And I get what, Beverly? Yeah, so those terms cancel out. So I get,
Does a 2x squared come down to?
yep, it still comes down 2x squared
And then plus 2x.
plus 2x. There it is. Thank you. And that kind of relates to Leo's question. Should there be a 0 there? And if it was a 0, then yeah, you'd still get 2 minus 0, which is 2. All right. What do I do next? So aside from Beverly. It's the same steps over and over, guys.
You bring down the one.
Bring down the 1, yes, you do. If I raise his hand next time, but perfect. Bring down the 1, so that's plus 1. Perfect. And then I'm trying to match up this 2x squared term so I can subtract it and get rid of it. How do I get a 2x squared term right here? What do I multiply x squared by to get 2x squared? Sam? 2. Nice. So I'm going to say a positive 2. And when I multiply 2, can someone else help me with the distribution? 2 times x squared plus 5 is what? Ellery? 2x squared plus what?
Plus 0x.
Yeah. So we'll go ahead and skip plus 10. All right. Moving on to our next color. What do we have? I have black again, I guess. What do we do next? Beverly. Subtract. So I put parentheses around here. I subtract and I get what? 2x minus 9. All right. And finally, our last step. What is my last step? Sam? It is indeed the remainder. What do we do with our remainder? So if I'm writing out my final answer, I have x plus 2. Yeah, so you do something with 2x minus 9. Do you remember up here we had a remainder of 4, but then we did something special to the 4? Why did we write over x plus 1? What should we write over here? It's going to be 2x minus 9 over something. So 2x minus 9 divided by, so this x plus 1 came from right here, x plus 1. No, it's going to be the thing that you're dividing by, this x squared minus or plus 5. Yeah, so x squared plus 5. And that's going to be adding, and we have our final answer. So that's our final answer, but we need to actually write it into Khan Academy's form. So if you have this question on the quiz, I'm not going to ask it weirdly like this. They have to ask it this way because they need data validation to make sure you got each piece right. So the quiz or tests, anything that's on paper for me, this is what you're going to write. But for Khan Academy, now you need to extract that information and put it in the right spot. Is it a question, Elder?
Yeah. On the first one, or that was really easy. So like first subtraction bit in this, when you have negative 3x minus 5x, because you distribute the negative, should not actually end up as 3.
Oh, yeah. So you're saying that there's a mistake right here?
Yeah.
You're right. Yeah. You don't add it straight down. We forgot to distribute the negative. So what should it be? Negative 8x. Good catch. Let's see, eraser tool.
also have a question. The x, like on, or the answer goes over the minus 3x term because that's like where you can make it, it's like 5x, but the x was over where you can make that.
Say that one more time.
The x and the answer is sitting, is like over the minus 3x term rather than the 2x squared term. Just because it needs like go by like terms, if you put it 5x is the code. I don't know how to.
So like, why did I write the blue X here instead of here? Is that the question?
Yeah, because I mean, you could have like x squared plus, or I guess not, because it's not like, because 5 wasn't gonna go with the 2x squared.
5 was not going to go. Oh, are you asking about this 5x?
No, sorry, this was really, or
Go for it.
like, if you multiplied by x, which we did, but you just had it over this 2. I think it's just because of like, it's fine.
Okay. I'll just go ahead and say okay because I'm not sure.
I don't
I
know.
really wish I could understand your question. I'm sorry. Okay. Well, I've edited our problem, so now I have everything correct, I believe. So what I want to do now is I want to turn it over to individual work time. I want everyone to try example 2, but I want to set it up for you. I want to set up the long division so we don't make the mistake of placeholder values. I have a feeling though, because of some of the types of participation I've been getting, I've lost some people. So after doing this example right here at the very bottom of the front side of the piece of paper, how many people have I lost? What's our fist of 5? Oh, the scores have actually gone up. That's awesome. We have 3. That's awesome. Okay, yeah. So let's move on to example 2. This is good. I'll set this one up for us. So the numerator is going to be a of x because it says a of x is the numerator. The denominator is going to be b. That means I'm going to be dividing this 3x to the power 4 minus 2x cubed plus 5. How many times does that go into 12x to the power 5 plus x to the power 4 minus 6x plus 2? The way that I set this up, and it's going to be really long, so I'm going to write it down here. Looks like this. I first have 3x to the power of 4 minus 2x to the power of 3 plus 5. And if you like placeholders right now, you can even use them now, but I'm just going to use them in the actual thing that I'm dividing into. So over here, I'm going to have the 12x to the power 5 plus x to the power 4. And then this is where the placeholders come in, plus 0x cubed plus 0x squared minus 6x plus 2. Question, Oscar.
Is there a method for that to be short?
Not that I know of. Beverly?
Why, we need placeholders for the outside part?
You could have placeholders if you want. It might make things easier. It's kind of like the same thing up here. You could have had a placeholder value and done x squared plus 0x, which meant you would have had a 0x here and or 0x squared here and a 0x here. So maybe that would be a good idea. It's up to you. I know that you don't need it as much. You definitely need it in this right-hand piece, but you don't need it on the left-hand piece. Yeah, Sam?
On the bottom, the second one.
For this one?
No.
Or example 2?
How'd you get 0x3?
So notice that this a of x term has an x to the power 5 term, has an x to the power 4 term. There's no x to the power 3 term. There's no x to the power 2 term, but there is a normal x term. Because we were missing those two, I put 2 placeholder values to say, hey, they're there. I need to worry about them when I'm doing my long division, but obviously they're not in the actual a of x polynomial. All right, you guys have the steps. Let's see how well you can do them. Yeah, Beverly.
So in the one before, you put the x over the 3x because those are both just x, right?
Yes, exactly.
But if it was like a x squared, it would go over the other.
Yep. And the reason that I do that is it, like, once I run out of values, once I stop right here, I know I'm done, and then the rest is the remainder.
What if you run out of things?
Say that one more time, please.
But what if you like, when you subtract like what you have left over, the numerator can't go into what you haven't like.
Like if this term was like a 0 or something?
Yeah.
Then yeah, you can just say the answer is x with the remainder of whatever over here.
Okay.
That works. All right, good luck, guys. So we made the change that this needs to be a 2x to the power 4 to make the numbers work out a little bit better. And I grabbed my stylus and I put it somewhere silly, didn't I? I can't write without my stylus. Where did I put it? There it is. All right. So first, what do I need to multiply 3x to the power 4 by in order to get to 12x to the power 5? Sam? 4x. And I can put that 4x anywhere that I want, 4x here, but the thing that makes the most sense is to put the 4x above the other x coordinate, so, or the other x. If I had a 4x squared, I would have written it right here, but I want to write it above the right spot. Okay, so I have 4x. Another volunteer, distribute 4x into these three terms. Yes. Yes. The reason that I do that also is once I hit this spot, then I'm done. Everything else is the remainder. It tells me when I have the remainder. Beverly, go ahead and distribute it, please. There it is. And then notice that I've written the terms underneath the same degrees. Everything in this column is degree 5. Everything in this column is degree 4, degree 3, degree 2, degree 1. My degree 1 terms are matched up. Next step. And I'm running out of time, so I'm going to go ahead and do it on my own. I'm going to subtract that entire polynomial from the previous polynomial. Beverly. A mistake?
No. It was supposed to be an 8 instead of a 6.
Good, okay. If anyone else caught that, go ahead and log it too. Then I subtract. These two terms are gone. I'm left with a negative 6x to the power of 4. I still have those placeholder values, so I'm just going to leave those blank for now. And I have plus 14x. And I'll go ahead and say plus 2. I'll bring that down. My last question, and I'm almost done, because notice once I get this value, everything else is the remainder. The last question really I have is, what do I need to multiply 3x to the power 4 by in order to get negative 6x to the power 4? Ellery? I forgot to distribute it, yeah. So it should be a 10x, right? It should be a 10x to the power 4. And a negative 26x. Okay. We will finish example 2 tomorrow.